All right, so you've probably seen the number by now, $7.6 trillion. That's what one Goldman Sachs model says the world could spend building artificial intelligence between now and 2031. And the internet did what the internet does. Half of it said the number proves AI is unstoppable. The other half said it proves we're in a giant bubble, about to pop. But here's the thing. They're both arguing about the wrong number. Because buried inside that Goldman report is one boring accounting assumption, the kind of footnote nobody actually reads. And that single footnote quietly decides two things: how big this whole build-out really gets, and whether big tech's profits right now are even real. So today, let's read the receipts. Not the headline, the footnote underneath it. So here's the claim I want to make, up front. That $7.6 trillion figure isn't a prediction. It's the output of a spreadsheet. And the most important cell in that spreadsheet is how long everyone assumes a single AI chip stays useful. Get that one number wrong, and the whole thing swings by about $1 trillion. Let me show you why. Now, what is that number really? Goldman Sachs Global Institute, that's Goldman's in-house research arm, added it up across 3 buckets: the chips, the buildings, and the power. So compute, meaning the actual AI chips, is the giant slice at 5.1 trillion. Then the data centers, the cooling and the racks, another 2.1 trillion. And the electricity to run all of it, 358 billion. That power number is the smallest one on the page. And weirdly, Goldman says it's the part most likely to break. Let's get the scale straight. $7.6 trillion is more than a quarter of everything the United States produces in a year. It's bigger than the entire economy of Japan. But here's the part that gets lost in the headline. Goldman says, in its own words, this is not a forecast. It's a scenario, a what if. And the number that model spits out depends entirely on a few assumptions you feed it. Change an assumption, change the answer. And one assumption matters more than all the rest. So what's the assumption? It's this. How many years does an AI chip stay economically useful? I know. Stay with me, because this is the whole game. When a company like Amazon or Meta buys a chip, they don't count the whole cost in 1 year. So they spread it out. That's called depreciation. You take the price of the thing and divide it across the years you expect to use it. Goldman uses a clean example. A single AI chip runs about $50,000, roughly a new mid-range car. And if you assume it lasts 5 years, you write off $10,000 a year. Here's why that one choice is everything. Goldman ran it 2 ways. Assume these chips stay useful for 5 years, and the implied depreciation across the build-out is around $3 trillion. Shorten that to 3 years, and it climbs to nearly $4 trillion. That's almost $1 trillion in extra cost. From one assumption about a chip's lifespan. Think about that for a second. That's roughly the entire Magnificent Seven's combined yearly profit. Apple, Microsoft, Nvidia, all of them. And not $1 of real cash has to move for it to happen. It's all in how an accountant fills in a single box. So which is it? 3 years or 7? Hold that question, because it's the exact fight everyone's about to have. Now, before the fight, let's make this real. Because 7.6 trillion sounds made up until you watch the deals actually get signed. In March of 2026, Meta signed a compute deal with a cloud company called Nebius, worth up to $27 billion over 5 years. And that's a small one. OpenAI and Oracle are tied together in a cloud arrangement reported around $300 billion. Over in Korea, NAVER, basically the country's Google, is building data centers with Nvidia at gigawatt scale. And a gigawatt is roughly 1 large nuclear reactor's worth of power just to feed the chips. And xAI's site in Memphis is now packed with over 550,000 of these chips. And the company selling most of them? Nvidia. And its CEO, Jensen Huang, isn't hedging. Useful AI has arrived, he says, and demand for these AI factories, in his telling, is extraordinary. He says Nvidia's newest platform, called Rubin, runs AI at up to 1/10 of the cost per token compared to the chips it replaces. Basically, 10 times cheaper to operate a model. Now that's Nvidia's own number, not independently tested. But Huang says the orders are real, about $1 trillion of them through 2027. So the spending is real, the deals are signed. Which raises the obvious question, where is all this money actually coming from? And here's where one of the most repeated facts online is just wrong. You've probably heard that the hyperscalers, that's the giant cloud companies, Amazon, Microsoft, Google, Meta, raised $725 billion of debt this year. But they didn't. That $725 is their spending, their capex, not their borrowing. And the actual debt is much smaller, somewhere around $175 to $200 billion in 2026. But, and this is the real story, a lot of that borrowing is built, so you can't easily see it. Take Meta, last October. It needed cash for its build-out fast. So it did two things in the same few weeks. First, it set up a separate company, what's called a special purpose vehicle, with an investment firm. The point of that vehicle? To build a data center in Louisiana and keep most of the debt off Meta's own books. Then it turned around and sold $30 billion of regular corporate bonds, the biggest investment-grade bond sale in America that entire year. Add it up, and Meta raised around $57 billion in a matter of weeks. And it's not just Meta. The Financial Times found more than $120 billion of AI data center spending has been pushed off balance sheets through vehicles like that. And when the US bond market couldn't swallow it all, the hyperscalers went abroad. Alphabet sold a record bond in Japanese yen, Amazon a record one in Canadian dollars. So the money's there, but it's borrowed, and a chunk of it is structured to stay just out of view. And those reported profits everyone's leaning on? They're what's supposed to pay it all back, which brings us right back to that footnote. Remember the question, 3 years or 7? Here's the fight. Quietly, over the last couple of years, the big companies all moved the same direction. They extended how long they assume their chips last. Meta stretched it from 3 years to about 5.5. Microsoft and Google from 4 to 6. And here's the trick. Every year you add lowers the expense on paper and lifts reported profit. Meta's stretch alone lowered its reported costs by roughly $2.9 billion. Enter Michael Burry. Yes, the big short guy. In November of 2025, he looked at those exact numbers and called it one of the more common frauds of the modern era. His argument is simple. Nvidia ships a new, faster chip generation every year or two. So a chip does not stay useful for 6 years. And by stretching the schedules, he estimates the hyperscalers are understating their costs by about $176 billion through 2028. Now, that's Burry's own model, not audited numbers, and CNBC couldn't verify it. Other analysts say he's confusing timing with fraud. But here's the kicker. One company already blinked, in his direction. Amazon, in early 2025, actually shortened the life on a chunk of its servers, from 6 years back to 5. And it said why. It cited the increased pace of technology development, specifically in AI. That one change cut Amazon's reported profit by about $677 million over 9 months. So the company with maybe the best view of how fast these chips age is the one quietly siding with the short seller. So where does that leave us? Honestly, with 3 possible futures, and that chip life number decides which one we get. Maybe the chips really do last 5-7 years? CoreWeave says its older chips still release at 95% of their original rental price, and the cloud giant's profit margins are actually expanding, not shrinking. In that world, the boom holds. Or maybe they age in 3 years, like Burry says, and $1 trillion of extra cost lands on the books, and a lot of today's reported profit quietly evaporates. Or maybe the chips aren't even the problem. Maybe it's that the customers never show up. Because here's the uncomfortable math. OpenAI has signed around $1.4 trillion in commitments against a revenue run rate, meaning its current annual pace, of about $20 billion. A US Senator, Elizabeth Warren, even wrote them a letter about exactly that gap. Then there's Bain & Company, which estimates the industry needs $2 trillion of new revenue a year by 2030, and will likely fall about $800 billion short. And an MIT study found 95% of company AI pilots haven't moved the bottom line yet. Not that the tech fails, but that the money hasn't shown up. Ray Dalio, who's seen a few of these, calls it the early stages of a bubble. And while Wall Street argues, the bill is already landing somewhere very specific: your power meter. In the largest U.S. grid region, data centers drove $9.3 billion of a single power auction price jump, a cost that flows straight onto customers' bills. And an ordinary family there is on track to pay about $70 more a month by 2028. As one utility law advocate, Elizabeth Marks, put it, households are already paying on the order of $1 billion more this year in generation costs. That's the trade: cheaper tokens on Jensen Huang's stage, and a higher electric bill in your kitchen. So here's the whole thing in one breath. 7.6 trillion isn't a prediction, it's a spreadsheet. The most important cell in it is how long a chip lasts. The companies stretched that number to look more profitable. A famous short seller called it fraud, and Amazon quietly agreed. The rest of us, meanwhile, are already paying for the build-out at the meter, while everyone waits to find out if the customers ever arrive. So, is it a bubble? Maybe. But that was never really the question. The real question is whether the single most important number in this entire $7 trillion build-out is one that almost nobody is actually reading. So, what's your read? Are these chips going to last, or is Burry right and the clock's already ticking? Drop it in the comments. I'm genuinely curious which way you land, and if this changed how you see that $7 trillion headline, subscribe. We read the receipts on this stuff every week, so the hype doesn't get the last word.